Hi everyone, welcome back to GridPro. In today's video, we'll explore how to use GridPro's automatic hole blocking tool to create blocks in the inner combustion chamber with cooling holes. GridPro's hole blocking tool is a time-saving feature that generates blocking for various types of holes with ease. Here we have a geometry of the inner combustion chamber featuring cooling holes. There are 7 rows of 24 holes each, and 1 row with 12 holes, all arranged circumferentially. These holes are distributed on both the inner and outer sides of the surface of the combustion chamber. GridPro's hole blocking tool is ideal for such scenarios, significantly reducing the manual effort required to create topology for each hole. Let's use this feature to generate the blocking for our geometry. The inputs that generate the blocks using the hole topology tool are surfaces where the hole starts and ends, a group which has all the holes for which the blocking needs to be created. Let's begin by creating one. We'll first group the hole surfaces using the Add Multiple Surfaces option. Then, we'll subtract the combustion chamber surfaces using the Add Subtract Surfaces Individually button. To enable automatic linking of hole topologies, we'll organize the holes at the same axial level into separate surface groups. Visually, the holes can be classified into 4 distinct groups based on their alignment, each group containing holes that can be linked both vertically and horizontally. Let's first copy the hole surfaces into new surface groups, keeping only those at the same axial level. We'll generate the blocking for these 4 groups in 3 sequential steps for better understanding. Since our flow domain extends on both sides of the holes, we will use two-sided holes, which allow for seamless linking with the outer topology on both sides. Enter the appropriate top surface ID and bottom surface ID. When separate surfaces represent the top and bottom of each hole, all top surfaces and all bottom surfaces can be grouped into 2 surface groups and provided as inputs to the group option. Let's start by creating a topology for the holes in surface group S1. It is recommended to use the 4-sided plus bidirectional topology type to add inserts to the hole topology. GridPro's hole tool can also automatically link the hole topologies. You can preview different linking patterns and select one if it meets your requirements. In our case, the holes need to be linked in a circular manner, which forms a closed loop, as well as in the axial direction of the combustor. However, due to the presence of multiple rows of holes, the tool may get confused and generate an abrupt linking pattern. In such cases, we can choose the hole centers pattern and manually edit it within the corner group. As shown, the selected corners are now grouped into corner group C1, indicated by the changing of the corner color from purple to yellow. Copy the inner and outer group of corners to the other corner groups for easier linking. Link the corners radially and longitudinally. Repeat the same for the outer group of corners. As seen, we've now achieved the desired linking pattern stored in corner group C1. Next, we'll delete the existing pattern in the corner group by enabling the Delete Pattern in CG flag. This ensures no disjoint topology is created by deleting the linking pattern after its use. Storing the peripheral faces in a separate corner group makes it easier to link them with other disjoint topologies. Clicking on Apply gives one-to-one connected hole topology for the holes in surface group S1. It creates an O-grid topology through and around the hole, which can be clearly visualized by taking the cut plane passing longitudinally through the hole. Let's now create hole topologies for the holes in surface groups S2 and S3. We will generate the hole topology for groups S2 and S3 in a single step. Group the holes in a single surface group and provide it as an input. Select the hole centers and link the corners manually to define the pattern. Use the corner groups to link the inner and outer corners efficiently. Also, make sure to link the first and the last corners of the loop manually. We will not link the last set of corners, as they belong to holes stored in a different surface group and are not aligned with the holes in the current linking pattern. Similarly, the outer corners are linked in the same fashion. The pattern gets updated in the corner group C1, which is given as input. Change the peripheral face group, then click Apply to get two disjoint hole topologies in one step. Now let's complete the hole topology generation for the last set of holes stored in surface group S4. Change the hole group input and choose a circular pattern that fits our needs. Add the peripheral faces to corner group C7 and click Apply to get a one-to-one connected circular hole topology. As you can see, we've now created topologies for all the holes with minimal effort. Switching to preview mode or block view gives a clear view of the blocking structure. In the current version, we still need to add inserts and link disjoint topologies manually. However, an upcoming version will include a feature to generate fully connected blocking for all holes in a single step. We hope this video was helpful in understanding the implementation of hole topology tool to save mesh generation time and improve efficiency. Refer to section 4.3.1 to learn more about the hole topology feature. If you have questions, feel free to contact support at gridpro.com. Thanks for watching.